Dear students, last classes you studied about phase control rectifiers which converts DC to AC, AC to DC, and inverters converts DC to AC. Suppose we want a converters, we want an application where we want AC to AC, AC from one frequency to another frequency. Then if we go by this method using converter and inverters, we need to have two stages of conversion. So, if we today we are going to I am going to introduce a new device called cycloinverters, which converts AC to direct conversion from AC to AC of one AC power of one frequency to AC power of another frequency. This is called cycloconverters. Today we will study about definition of cycloconverters, types of cycloconverters, single phase to single phase cycloconverters, advantages and disadvantages of cycloconverters. So, cycloconverter already told it is a device which converts input power at one frequency to the output power at different frequency with one stage conversion. So, that is called cycloconverter. So, earlier if you want to have a conversion AC to AC, we need to use a rectifier which converts AC to DC, again inverter DC to, this becomes a two stage conversion, also not efficient. So, now it is a cycloconverter, it is AC to AC only, but frequency is one frequency to another frequency. So, cycloconverter requires a one stage frequency conversion. So, cycloconverter we have two types. One is step up cycloconverter, where your output frequency will be greater than the signal frequency of S. This Fs. In step down converter, your output frequency less than the signal frequency or source frequency Fs. So, cycloconverter directly converts AC signals of one frequency to AC signals of variable frequency. This is application we find in speed control of AC motors. If you want to control the speed of AC motor, easiest thing is to vary the frequency. So, cycloconverters find application in controlling the speed of AC motors. Usually in cycloconverters are used for low frequency range. It finds application in low frequency high power applications. So, thyristor based cycloconverters are typically used in low speed, that is what I tell us, low speed high power application for driving induction motor and wind filled synchronous motors. So, usually here cycloconverters means application used for low speed and high power. This is what you have to remember. For varying the speed of synchronous motors and induction motors in the low frequency range and high power application, the cycloconverters are preferred. So, let us take up a step up cycloconverter. So, we have seen the two types of cycloconverter. We will be seeing the two types of cycloconverter. One is step up, where your output frequency will be greater than the source frequency Fs, and step down cycloconverters, where output frequency less than the input frequency or source frequency Fs. So, you are seeing a step up cycloconverter with a resistive load. We are using a center tap transformer for secondary. So, load is connected to a center tap as shown in the figure. So, we have four thyristors are used. We have two groups. One is positive group, the P1, the positive group P1 and N2. See the direction P1, this is the P1 direction or conducting direction, this is N2. This makes the positive group. In the negative group P2, in the negative group becomes, and supply voltage becomes negative. In that negative this becomes positive and becomes negative. So, the positive group is P1 N2, P1 N2. This is a positive group. Negative group that becomes forward bias during negative half cycle, that is P2 and N1. One in this group, one in this one. So, during positive half cycle this becomes plus. During negative half cycle A becomes the positive of half cycle A becomes plus, and during negative half cycle B becomes plus. Let us see the operation now. So, during positive half cycle P1 and N2 are forward biased. This is P1 and this is how conduction takes place, P1 and N2. Let us see the waveforms. So, when omega t is equal to 0, so this P1, and I already told you the P1 and N2 are forward biased. So, when my omega t is equal to 0, this P1 is turned on, the output voltage becomes positive. See the positive envelope, the output voltage is positive, it follows the positive envelope. At omega t, at time is equal to omega t1, the P1 is force commutated, P1 is turned off, and N2 is turned on. When N2 is turned on, so the output voltage becomes negative, it follows the negative envelope. So, this is the negative envelope and this is the positive envelope. Again at omega t, t is equal to omega t2, N2 is force commutated. Think in a step up converters, these are turned off by force commutation, this you have to remember. In step up cycloconverters, thyristors are turned off, forcefully commutated, they are commutated by forced commutation method. So, N2 is force commutated, now P1 is turned on, it follows the positive envelope. So, this is how we get an envelope up to up to pi, up to 180 degrees. Again during the negative half cycle, already told you the P2, this N1, P2, they are forward biased. So, at here this again P2 is turned on, it follows the positive envelope, again P2 is force commutated, N1 is turned on, output voltage becomes negative, this is how we will get envelope. You can see the frequency. Now, frequency is definitely higher than the source frequency. What is the source frequency? Fs. This is the first, this is the one cycle. See what is the Fs now, F naught output frequency? 6 times Fs. You can easily see the output frequency is 6 times the 1, 2, 3, 4, 5. See, it is 6 times the source frequency. So, it is a step up converter where the output frequency is 6 times the source frequency. So, what you know about learnt about in a step up converter? In step up converter needs force commutation, we need a center tap transformer, and number of thyristors required are 4. 4 thyristors required, you can see the diagram once again. So, center tap transformer. So, the positive group P1 N2 are turned on and turned off. So, negative group P2 and N1. So, this is how we are getting higher frequency than the source frequency. Here again 2 groups P1 N2, P2 N1. The output frequency here will be higher than the source frequency, and thyristors are force commutated. Let us summarize the working of step up converter. This already told you, during positive half cycle of supply voltage, SCR P1 and T2 are forward biased from 0 to 180 degree. P1 is turned on at omega t is equal to 0, load is positive, follows the positive envelope of supply voltage. At instant omega t 1, P1 is force commutated and N2 is turned on. The load voltage is now negative, follows the negative envelope of supply voltage. At instant omega t2, the N2 is force commutated and P1 turned on, and voltage is now positive and follows the positive. This is how we are getting the positive and negative of the output waveform. The output frequency here is greater than the supply frequency, that is F naught is equal to 6 Fs. So, in step up converter, the output frequency will be greater than the input frequency. We use a center tap transformer for secondary. We need 4 thyristors, 2 in one group, positive group, and 2 in another group. So, here thyristors are turned on by force commutation method. So, let us take up another type of cycloconverter which is used in speed control of motors, step down cycloconverter with R load. But single phase to single phase cycloconverters are seldom used. I use a major application of cycloconverter is in low frequency, high power applications. But understanding purpose, we are studying a single phase to single phase type of converters, understanding the concept of cycloconverters. See, here the bridge we use here two single phase phase control rectifiers are in a bridge configuration. One is called the P converter, which produces a positive output voltage, and we use the N converter which produces negative output voltage. So, this is how it connected to supply, both the sides, P converter this side and N converter connected to single phase supply. See, it is in bits configuration. How many thyristors are we using? 4, 4. 8 thyristors we are using here. So, P converter will be on for time T naught by 2 and N converter is on by for duration T naught by 2. So, we will getting a output frequency, it will be less than the input frequency. So, it is a step down converters. You can see the waveforms. So, this is another way of converting connecting a step down cycloconverter. The thyristors again. So, this is a P converter, this is N converter. See the direction of connection of thyristors here. See the direction. This is N converter, P converter plus VDC1. So, N converter minus this plus positive output voltage, this is negative output voltage. This is another way of drawing the same circuit. See let us see the output voltage waveforms. So, this is a Vx is a positive envelope of the voltage, this is the negative envelope is drawn. So, alpha is the firing angle. So, the two converters are fired in such a way that, so one converter gives a positive output voltage, the other converter gives the negative output voltage. See now the thyristor P1, P2 are conducting, here P3, P4, P1 and P2. So, this is when positive converter is on, this is for positive converter, this is for negative converter. This is current waveform, this is for positive converter, this is for negative converter. So, this you can see this is the envelope, you can see the envelope of output waveform. See this is the envelope output voltage. So, the frequency is 1/3. If supply frequency is 60, it will be 20 hertz. So, this is how we are getting output frequency less than the source frequency, it is step down. You can see the other waveforms, same type, same waveforms written in another manner. Here I am showing the P converter is on, this is the duration for which is P converter is on, this is the duration for N converter on. See the number of rectified pulse. So, this is a firing angle alpha P. This diagram clearly shows our firing angle, this is alpha N, these are where it is fired, this is the output voltage during when P converter is on. R is positive envelope. The negative envelope of the output waveform, this is we get when N converter is on. The frequency, the source frequency is 60 hertz, output frequency F naught will be 20 hertz. So, it is 1/3 of your input frequency or source frequency 60 hertz. The major application of these are most widely used. Step down is widely used. So, of step up and step down, the step down cycloconverters are widely used in low speed, controlling a speed of a induction motor or a speed of a synchronous motor. We use of course, we use a 3-phase to 3-phase, but for understanding purpose we are starting from a single phase. Here see the frequency is 20 hertz. Usually the application of cycloconverter range is 0 to 20 hertz, and the higher power of the is up to 15 maybe 15 megawatts. Very high power application cycloconverters are used. High power, low frequency, this you have to remember. Major application of cycloconverters, high power and low frequency. Low frequency may be 1/3. The range will be, you can have as a range from 0 to 20 hertz. We will see the applications later. Now let us summarize the principle of operation of single phase to single phase converter. So here I already told you the two single phase control converters are operated as a bridge rectifiers. Their delay angles are such that the output voltage of one converter is equal and opposite to that of one converter. This already told you. The P converter is operating alone, the average output voltage is positive. When P converter, already told you that P converter, when it is operating alone, the average output voltage is positive. When the N converter is operating alone, the average output voltage will be negative. And see if you want again. So in this P converter is operating alone, positive output voltage. When the N converter is operating alone, so we are getting negative. So this you have to remember. This already, the N converter is operating alone, the output voltage is negative. When P converter is operating alone, we will get a positive. So the P converter is on for T0/2 time. So N converter is on for T0/2. The frequency of the F0 is 1/T0. So alpha P is the delay angle of a positive converter. The delay angle of negative converter is alpha N is pi minus alpha P. So average output voltage of positive converters is equal and opposite to that of negative converter. VDC2 is equal to minus VDC1. So this is a 3-phase to single phase converter. See, you can see the diagram. This is only for information sake. Of course, it is not there covered in your syllabus, but for completion sake of cycloconverter, which used in practice, we use more in more of 3-phase to single phase or 3-phase to 3-phase. For that continuity purpose, I have taken this 3-phase single phase. You see, 3-phase input will be 3-phase. So here we get a single phase load is connected. Again we have a same type positive converter and a negative converter. Here the 3-phase power we are giving, we are getting output is single phase. It is maybe load, maybe a resistive or a inductive load. This is 3-phase to single phase converter. You can see the waveforms. 3-phase single phase converter, it is working principle is same here. Only thing we are using a 3-phase input. Again see the output will be single phase here. This is again P converter is on for, see the duration of single phase converter. It is on for T0/2 P converter, and N converter is on for T0/2. You can see the frequency is still further reduced. See 1 by maybe 12 5 is 60, 1/5. So Fs is 60 hertz. What is output frequency? It here 12 hertz. So this is a where we are using input is 3-phase and output will be a single phase. The frequency is still lesser than the previous case. It is F0 is equal to 12 hertz. This is how the 3-phase to single phase converter works. But another point you should note in step down converters. Step down converters are phase commutated converters. So we don't use any forced commutation here. Step down converters are phase naturally commutated only. They are phase commutated only. They are line commutated. We don't use a forced commutation here. So this is an important observation I think you should make. So in step up, I stressed there the thyristors are commutated, forcefully commutated. By forced commutation already studied in detail in previous sessions. So here they are line commutated, naturally commutated, line commutated one. So that is the difference between that is another advantage of step down converters. We don't need a complex circuitry for commutating thyristors. They are commutated. Force commutation is not required in a step down cycloconverters. So, let us take up the major the important one is which is in the practice. A 3-phase to 3-phase cycloconverters, it is can be implemented using 18 thyristors, 6 for each phase, 6 thyristors, 6 into 3, 18 thyristors. See, this is how it is connected to AC machine. One phase here, one phase here, one phase here. So, this is how I already told you the major application, important application of cycloconverters in speed control of AC machine. It may be induction motor or a synchronous machine. Very low speed in rolling mills in steel industry, very low speed and again reversible directions, it should run in both reversible directions. So, regeneration is also required. In such cases, the cycloconverter low speed means step down cycloconverters are used, and where we need a high torque, the working in a stubborn environment, tough environment, we use induction motors or synchronous machines. How they are controlled, how the speed controlled is done by cycloconverters only. So, this is the important application of cycloconverters, speed in AC drives or induction heating also it is used. It used industries, rolling mills and all. So, advantage, let us see the advantage of cycloconverter. So, cycloconverter already I told you it is a direct frequency changer. So, only in one stage we are converting AC power at one frequency to AC power at another frequency. It is a single stage conversion. There is no two stages of conversion here. So, in a two-stage conversion, we convert AC to DC, DC to AC if you want variable frequency or by AC power at another frequency. So, it is a direct frequency changer. That is a advantage of a cycloconverter. It is a direct frequency changer. Convert frequency to one frequency to other frequency in a single stage conversion. So, just now I told cycloconverter functions by means of phase commutation, that is in step down case. In step up we need force commutation. So, this is another advantage. We do not need any complex circuitry. When you want to go for force commutation, so in previous sessions we will study in detail different methods of force commutation. So, the circuit becomes complex. We need additional circuitry to commutate a thyristor. So, if we use additional circuitry, they are always associated with some losses. So, this is if you go for step down, no need of using commutation, additional commutator circuit. That is advantage of cycloconverter. So, another just now the application I told you, reversible drives. So, if you want to rapidly to change the direction of a motor, so cycloconverter is inherently capable of transfer either direction. That they are bidirectional. If you transfer the power in bidirectional, just now I told you, two converters, positive converter and negative converter. One is output voltage positive, another one is negative. So, another advantage here of cycloconverters, it can supply the power to loads at any power factor. Just now in application I told you, it is capable of regeneration over complete speed range down to standstill. So, there is another capability of a synchronous cycloconverter is it is capable of regeneration. So, this is used in reversible drives. So, here another advantage, if there in case a commutation failure occurs, that is short circuit of AC supply, but if an individual fuse blows off, a complete shutdown is not necessary here. So, converter continues to function with some distorted outforms. Of course, without output will get distorted waveforms. This is other advantage. So, cycloconverter delivers high quality sinusoidal waveforms. Cycloconverter delivers high quality sinusoidal waveforms at low output frequency. So, this is very much required for very low speed applications. So, waveform is pakka sinusoidal waveforms at low output frequencies. So, this cycloconverters are very useful for large power. This I made it on this point earlier also, is very attractive, or it is preferred for large power. So, this you have to remember, large power, low speed. So, the cycloconverters are attractive for large power low speed drives only. So, this is a most important application or useful application. This other it becomes very cheaper for large power low speed drives, the cycloconverters. So, what are the disadvantages of cycloconverter? So far we have seen the major advantages. Advantages are more than the disadvantages. So, only a few disadvantages of the cycloconverters are we need more number of thyristors. So, you see in for 3 phase to 3 phase we have seen 18 thyristors are required. So, again control circuitry becomes more complex because for firing and all. So, it is economical for already told you it is above 20 kVA maybe. It is economical to use a cycloconverters for high powers only, not for low power. For reasonable power output and efficiency, the frequency is limited to 1/3 of input frequency. They have seen if source frequency is 60 hertz, the output frequency we got 20 hertz in a single phase down converter. In a 3 phase single phase, 3 phase to single phase we got is 12 hertz. For reasonable power output and efficiency, so this is a low power frequency, low output frequencies are preferable, more advantageous to use in that way. So, the frequency range I already told you between maybe 0 to 20 hertz is economical to use, low frequency high power. The another disadvantage here is low power factor is very low, particularly at reduced output voltages. This is one disadvantage, low power factor. 3 disadvantage, low power factor, more number of thyristors, but very high efficiency and all. The frequency is limited to 1/3. These are the 3 disadvantages. First disadvantage is more number of thyristors required. Second disadvantage is the frequency is limited to 1/3 of the input frequency for reasonable power output and efficiency. Again, low power factor operations. These are the 3 disadvantages of cycloconverters. The major advantage of cycloconverter is single stage conversion, widely used for low power, high power, low frequency applications, and pure sinusoidal waveform you get. So, these are the advantages and these are the disadvantages. So, these are the several applications of cycloconverters. The major application just now I told, it is speed control of AC motors. If you want to vary the speed of AC motors, you have to vary the frequency. Efficient method of varying the speed, varying the frequency. And cycloconverters are just fit for this application, for especially for low speed application requiring in rolling mills in steel industry. Again, for converting a variable speed alternating voltage to constant frequency output, we for voltage for use in power supply in aircrafts. So, we use the cycloconverters. So, output from alternators, variable speed alternator voltage, if you want the frequency will be variable. So, if you want a constant frequency, so go for cycloconverter. Used in controlled induction heating, cement mill drives, rolling mill drives, skid base drives, or grinding mills. It is used in mining also. We will see some of the applications, practical use of applications later slides. So, already told you cycloconverters are used in high power drives where the ratio between input and output frequencies is in the range 6:1 or greater. Cycloconverters are capable of operating at high power levels in excess of 100 megawatts. 100 megawatts, again providing 4 quadrant operation, providing lagging, leading power factors and bidirectional power transfers, reversible drives, both forward and reverse directions, especially application like steel rolling mills. So, these are preferred. In tough environments where very high torque is required for induction or synchronous motors, we use cycloconverters. So, this is in a practical application cycloconverters. Just I am repeating the rolling drives, where importance of the cycloconverter is rolling drives for rolling mills. See here, see the speed of frequency is required. Rolling drives that runs continuously, typically we have a 6-pole cylindrical rotor synchronous motors. Synchronous motor, I think method studied by now, which runs at synchronous speed. So, induction motors never runs at synchronous speed, whereas synchronous motor always, if it runs at synchronous speed only. Induction motor never runs at synchronous speed. This is the major difference between induction motor and synchronous motor. See the rated frequency here in rolling drives. This why, that is what I am showing the picture wherein practically it is used in industry. The approx frequency is 7 hertz. Speed, if for 7 hertz you can calculate the speed, it is approximately 140 rpm. The maximum frequency approximately 20 hertz, that is 400 rpm. So, cycloconverters are typically used application, the frequency is 0 to 20 hertz. This you have to remember. Whenever somebody ask about cycloconverter, the frequency range typically used in practical purpose is 0 to 20 hertz. So, this is a practical application. You can see the drives, rolling drives, frequency rated frequency 7 hertz there, very speed, low speed 140 rpm, that used in synchronous motor. So, that low speed controlling a synchronous motor at very low speeds, cycloconverters are used. So, remember cycloconverters, low speed, high power applications. They are economical only for high power, very large ratings, otherwise they are not economical, and they are very attractive for low frequency and high power. So, this is a typical application, rolling drives or rolling mills. Observe the frequency, you need to observe the frequency here. So, maximum 20 hertz and the rated frequency there is 7 hertz. So, the frequency range is 140 rpm to 400, that is very low speed they will run. Low speed, high power cycloconverters, that is how you have to remember. Step down converters. So, practically we use step down converters, that to 3 phase. Either 3 phase to single phase or 3 phase to 3 phase. So, this is another use of cycloconverters for ore grinding mill. So, this cycloconverter, this only you will get an idea where we use cycloconverters, ore grinding mill. This is another type of cycloconverters, maybe different power rating. This power rating is up to 36 megawatts. So, this gets highest marks in robustness and reliability. So, this is again converters used for large induction motors and synchronous motor, large power rating. The cycloconverters, the power rating is 36 megawatts, but range is up to 0 to 150 megawatts. You can use cycloconverters, very high powers. They are economical for high powers. So, cycloconverters for synchronous motors and induction with a very high torque. If you want a very high torque induction motor, synchronous motors, cycloconverters are used. See the picture shows maybe crushing, it may be used in mining and all. So, where we need a high torque, for this type of application we need a high torque. For speed also has to be very low here. So, we go for cycloconverters in these applications where we need a very high torque. So, just now I told the powering, for powering of ore crushers, ore conveyor belts, mine winders for underground mining. So, where high power drives are required, high power low speed drives. So, in such cases we go for cycloconverter. See, they have written the megawatts, 3 to 36 megawatts of cycloconverters. The power range is 3 to 36 megawatts. You can note down the applications again. I am repeating here. There for powering ore crushers, ore conveyor belts, mine winders, and underground mining. These are the applications. Mining, ore crushers, ore conveyor belts will run at very low speeds. So, we can use a particular cycloconverters. So, let us see, these are topics covered just now. We have seen the definition of cycloconverter. Cycloconverter is a direct frequency changer which converts power, AC power at one frequency to AC power another frequency. It is a direct frequency changer on single conversion stage, no two stage conversion. So, we have seen types of converters, two types of converters, step up, step down converter. In step up converter, the output frequency is higher. Just now we have seen a mid type cycloconverter. We used center tap transformer and 4 thyristors, where the output frequency is higher. Fs is equal to 6 times the F naught is equal to 6 times the source frequency. So, another type of converter we have seen, step down microconverter. In step down microconverters, the output frequency will be lesser. F naught is lesser than the source frequency. In our single phase to single phase converter, we see the frequency, output frequency is 20 hertz, input frequency 60 hertz. It is 1/3. F naught is equal to 1/3 the Fs. And we have seen the advantages of a cycloconverter. So, the major advantage is single conversion. For step down converters, no commutation circuits are required. So, in step down converters, no commutation, no force commutation, no additional commutation circuit is required. Whereas in step up, we need to commutate them by force commutation method. So, step down converters are advantages, less complicated circuitry, and also here we go for high power applications, low frequency high power applications. We can use them. Again, we can use them for any load power factor. Again, it is a pure sinusoidal waveform we get. These are some of the advantages we have seen. We have seen this disadvantages. The major disadvantage is more number of thyristors required. That is one of the disadvantages. Again, we see the single phase to single phase cycloconverters. We have seen in detail. Single phase to single phase cycloconverter, we have seen both step up and step down. In step down, we have saw 2 phase controlled thyristors are connected in a bridge configuration. So, P converter and N converter. The P converter works for T naught by 2. So, N converter works at T naught by 2. The frequency we saw is equal to 1 by T naught, and if input frequency is 60 hertz, the output frequency we got is 20 hertz. And we saw a 3 phase, we discussed about 3 phase to single phase cycloconverters, where the output frequency was 12 hertz. Again, we discussed about the practical application where we use a 3 phase to 3 phase. We found a 3 phase to run a 3 phase induction motor, to speed control of a 3 phase induction motor, to speed control of a synchronous motors, where we use a 3 phase to 3 phase cycloconverters. And we saw the different application of cycloconverters and AC drives, and we see the different application of AC drives there in rolling mills, in mining, mine winders, for powering our over conveyor belts, and induction heating. So, these are the different application of cycloconverters. So, what are applications? So, the all common thing is cycloconverters are more attractive when we go for low frequency high power applications. So, they are very attractive, they are economical also. So, you have seen the rolling mill drives application, where they need a very high torque synchronous motors, high torque running synchronous motors with high torque, application requiring high torque, induction motors, and also their high reliability also is there, very high torque, very tough environments also we can use them. So, So, the cycloconverters are used in such applications requiring low frequency, high power. The power, we have seen the range of power also, megawatts. The maximum maybe it ranges is up to 150 megawatts. The particular cycloconverter I have shown is 36 megawatts, used for very high torque synchronous and induction motors used in rolling mills, in steel industries, even mining industry. In mining, where we use drives, how to operate a drive, we need a cycloconverter. How to vary the speed of a drive, AC drive, maybe synchronous or induction motor. And we see the particular application, the speed range, frequency required is 7 hertz and maximum frequency 20 hertz. The speed range was 140 rpm to 400 rpm. So, to control such a very slow speed motors, very high power rating motors, so we invariably go for cycloconverters. We have seen the more advantages than the disadvantages. Cycloconverters, the major important points you need to remember of cycloconverters, the frequency range is 0 to 20 hertz. Frequency range, maybe step down application 0 to 20 hertz step down. Power rating we have seen up to 150 megawatts. The particular thing, particular microcontroller we have seen is 36 megawatts. So far, now we have seen all the types, bridge rectifier, inverter, choppers and cycloconverters. Cycloconverters are very high power ratings are used. So, thank you. Have a nice time.